Okay, so good afternoon, all of you. We have seen 8086 architecture, right? In that architecture, we are having two parts, BIU, EU. BIU will fetch the instruction, decode it, okay? Execution unit will be executed, right? In execution unit, you are having two registers. One is temporary register, okay, and one is flag register that we have seen. Both are this of 16 bits. Yes? Hello.
Yes, sir.
This we have seen. So temporary registers are needed for some storing some temporary data, like we have seen the example of swapping of two numbers that we have seen. So for that kind of purpose you require this temporary register. Flag register is needed to know the status. Now flag register is of 16 bit, as you can see over here. These are the 16 bits, okay, and there are total 9 flags. Flag means flag is a single bit data, right? One bit data. It can be one, it can be zero. If flag is one, that means the flag is set. If that bit is zero, flag is not set, reset. Yes. Hello.
Yes, sir.
We have total 9 flags and we have 16 bit register. What that mean? 7 bits are useless. So whenever, like at whatever place I have written X, that place is not used. So we can simply ignore that places. In this register, these places are not used. Other than that, there are 9 flags that we are going to use. Now what flags do? Flags will tell us the status of current result. What it do? It will tell us the status of current result. Okay, so whatever your current instruction is, after the execution of that current instruction, whatever result you get, based on that flags are getting set or reset. Done. Hello. Yes. Are you there?
Yes,
Yes,
sir.
sir.
Okay, now there are 9 flags. Out of that 9 flags, 6 flags are called status flags, 3 are called control flags. Now why 6 are called status flag? Because it is giving us status and it is governed by microprocessor. So status flags are handled by microprocessor. We can't do anything with this flag. We can just use that status for programming purpose. Okay. While 3 flags are called control flags. Why control flag? Because user can control this flag. We as a user can set or reset this flag for our purpose. So that's why these 3 flags are control flags. This much thing is clear. Done.
Yes, sir.
Hello. Okay, so let's start and try to understand each and every flag. So first we'll understand all the status flags. Okay, there are 6 flags in status flag. So we'll start with that. First is called carry flag. This is your carry flag CF. What it will do, if it gets set 1, that means carry is generated out of MSB. Keep this in mind. Carry is out of MSB. What that means? Suppose I'm having a number like this, plus 10101010. If I do the addition, what will be the output? 1 plus 0, 1. 1 plus 1, 10. 1 plus 1, 10. 1 plus 1 plus 1, 11. Carry 1. 1 plus 1, 10. 1 plus 1, 10. 1 plus 1, 10. 11. And carries 1. Understand? So, bit. The leftmost bit is called MSB. The rightmost bit is called LSB, least significant bit. Yes? Hello? Hello? Are you there?
Yes, sir.
Hello?
Yes, sir.
Yes. So this, see, carry is generated over here also, and carry is generated over here also. So if At the end, if carry is generated, then only carry flag will get set. So in this case, CF will be 1. Done. If here carry is not generated, then it will be 0. Done. As you can see, there are so many carries generated throughout this number, but all that doesn't matter. Only if carry is generated over here, then only we'll set the flag. So what CF flag will do? CF is carry flag, and it will get set when carry is generated at MSB, most significant bit. Done. Hello. It is quite simple. Yeah. Hello.
Yes, sir.
Okay. Next is parity flag. Now parity flag will tell us the number of ones and zeros in your number. So it is 1 when you are having even parity. It is 0 when you are having odd parity. I think we have seen parity generator in digital electronics. Still, for the reference, suppose my number is 10111100. Here I am having 2, 3, 4, and 5. 5 number of ones. That means it is having odd parity. If I am having a number like this, 1101, here I am having 6 numbers, so it is even parity. So if this number is there, parity flag will contain 1. If this flag, like this number is there, my parity flag will contain 0. Easy? Yes? Hello? Clear? Is
Yes,
it
sir.
fine? Yeah, so parity flag will tell me that how many number of ones are available in my result. That's it. So that's why parity flag is used. It is again a status flag. Next flag is zero flag. It is again the simplest flag. If my result is 0, 0 flag will become 1. If my result is not 0, it becomes 0. Okay? Yes. If I do 6
Yes, sir.
minus 6, my output is 0. In this case, my 0 flag will becomes 1. If I do 6 minus 5, output is 1. My 0 flag will become 0. Done? Yes.
Yes, sir.
So this is again one of the simplest flag. No need to worry. Now this is interesting. AF, auxiliary carry flag. This will becomes 1 when carry from lower nibble to higher nibble. Okay. And this is normally used in 8-bit operations. What do you mean by that? 11001010 plus 11001100. In this case, this is called lower nibble. This is called higher nibble. The lower 4-bit is 4-bit is called nibble, right? This is lower part, so lower nibble. This is higher nibble. So if carry is generated after this to this, then your auxiliary carry flag will get set. So suppose we'll take number 10100011 plus 11000100. Chalo, do the addition. 1110011 10. So 0 1. Can you tell me carry flag will set or not? Fast. Can someone answer me?
Yes, sir.
So CF will be
Yes,
1.
sir.
Auxiliary carry will get generated or not?
No, sir.
Here we have no carry, so AF will be 0. Yes? Yes?
Yes, sir.
Yes.
Okay, again, just give me answer fast. 00111100 plus 1010 Okay, so here 0, 1, 1, 1 plus 1, 10. Carry will be 1, 1 plus 1, 10, 1, 11, 1, 1, 1. Now CF flag will be fast.
0.
0
Zero.
because no carry from MSB, right? Okay, and auxiliary carry
1.
One.
1 because here you have one carry generated out of this nibble to this nibble. Done? Yes.
Yes, sir.
So this is done. So this is also not that difficult. Now next is sign flag. Now listen it carefully. Yeah? Sign flag. Sign flag is 1 when your MSB is 1. Sign flag is 0 when your MSB is 0. That's it. This is what your sign flag do. Okay. Now why we use sign flag? To like we use it with signed numbers first of all, and it will tell us that number is positive or negative. Okay. Now checking number positive or negative, we'll use sign flag, but it is not always correct. Okay, so first try to understand what is. Okay, first of all, you people tell me that suppose for this number, what is my sign flag value? Sign flag will be 1 or 0? Fast.
0.
1. It simply takes your MSB. Here
Actually
MSB is
positive.
1, so this is 1. What is the sign flag value here?
0.
0, because my MSB is 0. Clear? What is the sign flag value for this? 1, because this MSB is 1. 0, 1, 0, 1, 0, 0, 0, 1. What is the value of sign flag?
0.
0, because my MSB is 0. So this is how sign flag works. Now let's discuss some concepts of numbering, right? Because it is used for number checking the number is positive or negative. Okay, first of all, there are two forms of numbers: unsigned numbers and signed numbers. So if we talk about 8-bit, the maximum number that you can store in unsigned number is 0 to 255. What that mean? Suppose I am having a 8-bit number available like this. Okay, so here this is my 8-bit, and all bits are used to represent number. So 0, 0, 0, 0, 0, 0, 0, 0. This is the minimum number that I can store. And if you can convert this into hex, 00H, right? Hello.
Yes, sir.
Okay, and the maximum number that I can store here is what? 11111111 F F H. So what is the value of FF? 255. So what are the decimal numbers that I can store? 0 to 255. Done. So if my number is unsigned number in 8-bit, I can store 255 as my biggest number. If I want to store 256, I want 9-bit. Yes? Hello?
Yes, sir.
This is clear? Okay. Now, let's go back here. In signed numbers, as you can see, 1 bit is used to represent sign. So if sign bit is 1, it represents negative number. If sign bit is 0, it represents positive number. And to represent a magnitude, you have only 7 bit with you. So the range of signed numbers are minus 128 to 127. How? Let's see. So if this is my 8-bit, 1, 2, 3, 4, 1, 2, 3, 4, 0, 0, 0, 0, 0, 0, 0. If this bit is used as sign bit, so this can't be calculated in magnitude. So if this bit is 0, what will assume that this number is positive? If this bit is 1, we'll assume that this number is negative. Understand? Hello? Hello? Yes. So we have only effectively 7 bits available, and 2 raised to 77 is equal to
128.
8. So minimum number that you can store is 0 to 127, because 0 is also considered. And the biggest minus 1 to minus 128. So total 128 numbers you can give. Done? Hello?
Yes, sir.
Okay. One more thing. How negative numbers are stored in memory? Suppose I want to store minus 10. How to store this thing in memory? Can you tell me? Can someone know?
0, 1, 0.
No, like how to store it. Just tell me the basic. If I want to store any negative number, how to store that negative number into memory?
Sir, 2's complement કરીને થાય.
Very nice. 2's complement. Exactly. This is which is used to store any negative number. So if I want to store 10, I first need to write down the binary of 10. That is 1010. Then I need to find out 2's complement of this. 0110. Yes? And if
No,
I
sir.
store, huh?
Yes, sir.
If I want to store this number into memory, it will be stored like this. First 1. So this represent negative number. This is 0, 1, 1, 0. And this bit remains 0. Yes?
Yes, sir.
Now this will represent minus 10. Understand? Yes. So
Yes, sir.
if we find one over here, what we'll do? We'll take this number and find that it's a 2's complement of which number, so that we can get to know that this is actually a, sorry, here 1 1 will be there. So what happens? 1 1 0 1 1 0. We'll find out the 2's complement of this 0 1 0 1 0 0, and it is a 10. Yes. Yes. Hello.
Yes, sir.
So now we can say that it is a negative number. So minus 10. Get it? So if you are having a signed number, it will store lesser number. If it is unsigned number, you can store more numbers, right? Now problem is sign flag is used to tell you that number is positive or negative. So normally if we are having a sign number, we are using sign numbers. If these are my 8 bits, wait a minute. If these are my 8 bits, and if I am having 1 over here, you can simply say the number is negative. By seeing here, if it is 0, you can say number is positive. Yes. Hello.
Yes, sir.
Hello. But that is not the case. Why? Because see, now see the example carefully. As I said, sign flags are giving you wrong output. Why it gives you wrong output? See, here is the example. What is the maximum number that you can store 8-bit number in sign flags? 127. Yes. So that is this 0, all one, 7 F. So if I do 48 plus 49, what happens? I will get the answer 91. Yes. This is hexadecimal number. So 8 plus 9 is 11 in hex. 8 વત્તા 9 17, 17 ને હેક્સમાં કન્વર્ટ કરો એટલે 11 થાય. યસ. હેલો. Are you there? Are you there? Am I audible? Meet, Harsh, am I
Yes,
audible?
sir.
Okay. Addition is not my cup of tea right now. You can do it later on also. Hexadecimal addition. What I'm trying to tell you is 48 is positive number. 49 is positive number. I am adding these two numbers. So answer will be 91. Okay. If I store this 91 into memory, it will be stored like this 1001 0001. For 1, you are having 4 digit. For 9, you are having 4 digit. Fine. Yes. Hello.
Yes, sir.
But you can see the answer by seeing this. My sign flag. What is the value of sign flag after this addition? SF will be sign flag will
1.
be 1. Sign flag is simply taking your MSB. So what it indicates, my number is negative.
Negative.
But you are adding two positive number. How your number can be negative? That is not possible. Yes. Hello.
Yes, sir.
But why this thing happens? Because the range of our 8-bit is 7F. So anything which is more than 7F, it is actually going again round, like so. If number is bigger than 7F, it is called overflow. Your memory can't handle this number. You can't store 91 with 7-bit, and that's why it is overflow occurred. So whatever result you have received right now, it is wrong. And that's why sign flag is not giving you perfect answer. What that mean? If overflow doesn't occur, then whatever sign flag is telling you is right. So if your answer is within minus 128 to plus 127, whatever your sign flag is giving you the answer, it is correct. But if overflow occurs, in that case, whatever answer given by sign flag is wrong. So if sign flag is representing 1, you need to consider 0. If sign flag is representing 0, you need to take it as a negative number. Understand? Hello. Hello. समझ पड़ी?
Yes, sir.
if I am adding two numbers or if I am doing subtraction of two numbers, if my number is more than 127 or minus 128, in both these cases, what happens? Overflow occurs. If overflow occurs, sign flag will give me wrong output. If overflow doesn't occur, sign flag will give me exact output. Okay? Okay, done.
Yes, sir.
Okay, and how to check overflow? So for that you are having overflow flag also. One of the status flag is overflow also. Here it is. So sign flag, zero flag, auxiliary carry, parity, carry, and overflow flag. So if overflow flag is one, you need to understand that overflow is occurred. So you need to not considering the sign flag. If overflow flag is equal to 0, sign flag is giving you right answer. Done. So if I want to check whether the given number is positive or negative, what I'm supposed to do is here if it is 1, so my sign flag will contain 1. Yes? Yes. Now overflow flag. So what I need to do is every time I need to first check overflow flag. Is overflow flag is equal to 1, that means overflow occurs. So this result is wrong result. So actually result is 0. So my number is positive. If overflow flag is equal to 0, then this number is correct. So my number is negative. Understand? So every time if you
Yes, sir.
want to check that your number is positive or negative, first thing that you need to check is overflow flag. If overflow flag is equal to 1, invert this sign flag. If overflow flag is equal to 0, you simply need to consider sign flag directly. Fine? This is done.
Yes, sir.
Okay. Now all these flags are governed or handled by microprocessor and it will give us the status. So that's why they are called status or conditional flags. Okay. Done. Now there are three flags which are used by programmers and that's why they are called, what it called? Control flags. Done. Hello, are you there?
Yes, sir.
Okay, this thing we have already covered. Number is negative, sets, two's complement. Okay, so just for the sake of understanding, we'll put this slide for 2 minutes so that if you watch video later on, you can get it. Chalo, back here. First control flag is trap flag. Now, if trap flag, now it is handled by user. So in programming, if I do trap flag is equal to 1, what that means? I am telling the microprocessor to do single stepping. Now, what is single stepping? If you do C programming in any compiler, you can trace your program. Yes, by F7 key. Yes. Hello. All of you are familiar with the concept of breakpoint? Hello. Are you there? Meet, Harsh, Vatsal, Ved.
Yes, sir.
Okay, so all of you know about the concept of breakpoint. In
No,
C
sir.
in C program, if I write a big program of 100 lines, okay, I don't get any syntax error, but my output is not coming as expected, right? So what you are supposed to do is you need to check the code that where my logic is wrong. Yes.
Yes, sir.
So how you can check it? So suppose you know that my first 50 lines are perfect. There is no mistake. So at 50 lines, you can put breakpoint. And after that, you can do F7 key press and do single stepping. So I will check my result after this step, this step, this step. And I think that here I am getting wrong result. So there must be something wrong with this line. This is how you can trace your code. This is how you can debug your code. It is called a breakpoint. In C, you can do using F7 key. Yes, turbo compiler. Get it? Hello.
Yes, sir.
Same thing if you want to do with your assembly level code. If this is my code, I know that this is a big code and here there must be something wrong. So here I can make the trap flag is equal to 1. So after this line, my assembler will check each and every line and give me the result. And whenever I find that now it is fine, I can make trap flag is equal to 0. So it will allow me to trace my code. That's how trap flag is used. Done? Hello?
Yes, sir.
Okay. Next is interrupt flag. Normally, microprocessor is handling interrupts. It is not generating interrupts. So suppose keyboard is there. If we are pressing a key on keyboard, then you are generating actually a keyboard. Sorry, interrupt, and your processor will handle it. So if I make it 1, it will enable the interrupts. By default, it is 0. By default, all the flags are 0. So enable is not interrupt. What that mean? Initially, you can't do anything. A best example of interrupt flag is your mobile phone. When it is switch off, when it gets turned on, interrupt flag is by default 0. So you can't generate any flip flop interrupt. So you can't press any key or anything. Once your OS get loaded, interrupt flag will set to 1. So now then you can press your key or do any operations. Understand?
Yes, sir.
More in detail we'll see when interrupt comes in microprocessor. We'll study this thing in detail later on. Fine? Yes.
Yes,
Hello.
sir.
The
Yes.
moral of the story is currently interrupt flag is used by user. We can set to 1 or 0 based on our requirement. If it is 1, it will accept interrupt. If it is 0, it will not accept interrupt. Fine? Yes. Yes.
Yes, sir.
And last point, direction flag. So DF is a direction flag. So many times you want that, suppose this is one array, this is one array, you want to transfer this array to this array. So one way is you can go in ascending order. Some other user who is think different can go in reverse direction also, right? Yes. Hello. Are you there? This
Yes,
is one.
sir.
Yes, sir.
This is one array which contains 3 elements. This is one array which contains 3 elements. 1, 2, 3. I want to copy this content here. So I will first copy 1, then copy 2, then copy 3. If I want to write down C loop, I need to have a for loop which runs 3 times. Yes? Yes. If this is my
Yes,
x
sir.
variable, in for loop, I will increment x variable every time. X plus plus. Yes? Yes?
Yes,
Yes,
sir.
sir.
Another way is I am having z variable which pointing to 3. This loop runs 3 times. Every time first I will copy 3 here, then I will do z minus minus, then 2 will go, then 1 will go. Yes? Possible?
Yes, sir.
So based on your requirement, you can set the direction in positive direction or negative direction. Okay. So that's what is done by direction flag. So it will allow us to set the direction. We want to go upward or downwards. Okay. 1 will be auto decrement, 0 will be auto increment. Okay. It is used with string operations. Fine. Hello. Direction flag will use with string operations. If we will set it, it allow us to auto decrement. 0 is default value. So default we always do increment, right? જે નોર્મલ છોકરા હોય તે નોર્મલી x પ્લસ પ્લસ જ કરે. જે વિચિત્ર હોય તે લોકો ખાલી z માઇનસ માઇનસ કરે. So by default, if you want to decrement it, you can make it 1. Otherwise, by default, it is 0 increment, right? So no need to mug up. You can simply remember by default all the flags are 0. So if direction flag is 0, what it will do by default? Increment.
Increment.
Yes. Done. So these are your 9 flags. Done.
Yes, sir.
Hello. Okay, by default all flags are 0, and this is what your assignment is. Write down your notebook if you want to write it down. Okay, let me stop recording because we have almost covered everything for flags.